The equations of the two graphs shown below are y sub 1 of t equals a sub 1 times the sine of b sub 1 times t, and y sub 2 of t equals a sub 2 times the cosine of b sub 2 times t, where the constants b sub 1 and b sub 2 are both positive real numbers. The question is, which of the following statements is true of the constants a sub 1 and a sub 2? So we're looking for a comparison of a sub 1 and a sub 2. One thing to note, the larger the number in front of the expression, the taller the curve. You see y sub 1 of t has a taller curve than y sub 2 of t. Likewise, the smaller the number in front of the expression, the shorter the curve. So y sub 2 of t has a shorter curve than y sub 1 of t, verifying that a sub 1 is greater than a sub 2. Another thing to point out, the wave goes up first on y sub 1. That means that a sub 1, the number in front, will be positive. If it was negative, it would go down first. So with all that said, put that all together, you can see that 0 is less than a sub 2, which is less than a sub 1. So a sub 2 is less than a sub 1, but they are positive, so they are both greater than 0. 0 is less than a sub 2, which is less than a sub 1. Letter B. For x such that 0 is less than x, which is less than pi over 2, the expression the square root of 1 minus cosine squared of x over sine of x plus the square root of 1 minus sine squared of x over cosine of x is equivalent to which of these? You do have to have some knowledge on trigonometric identities in order to have a shot at this. Sine squared of x plus cosine squared of x is equal to 1. Now if you subtract cosine squared of x from each side, you would have sine squared of x is equal to 1 minus cosine squared of x. Or if you take that and subtract sine squared of x from each side, you'd have cosine squared of x is equal to 1 minus sine squared of x. So you can substitute in. Where it says 1 minus cosine squared of x, you can substitute sine squared of x in for that. And where it says 1 minus sine squared of x, you can substitute cosine squared of x into that. Now the square root of sine squared of x, that would just be sine of x. And the square root of cosine squared of x would be cosine of x. So you have sine of x over sine of x, it's going to be 1. Cosine of x over cosine of x, it's going to be 1. And I think we can handle it from here. 1 plus 1 is, of course, 2. And that is letter H. Consider the functions f of x equals the square root of x and g of x equals 7x plus b. In the standard xy coordinate plane, y equals f of g of x passes through 4, 6. What is the value of b? So f of x equals the square root of x and g of x equals 7x plus b. That's given to you. Y equals f of g of x. That passes through this point 4, 6. So if we take f of g of x, in other words, substitute 7x plus b in 4x into f of x. So we're replacing the x in f of x with this 7x plus b. Now we have y equals the square root of 7x plus b. Remember, y is 6, x is 4, so we can put a 6 in for y and a 4 in for x. Your job is to find the value of b. So if we substitute in, now we have 6 equals the square root of 7 times 4 plus b. 7 times 4 is 28, so it'd be 6 equals the square root of 28 plus b. Square both sides. If you square each side, you get 36 equals 28 plus b. And then subtract 28 from each side to solve for b. You end up with b equals 8. 36 minus 28 is 8. b equals 8, and that is letter A. Triangle XYZ that is shown below has side lengths of x, y, and z inches and is not a right triangle. Let x prime be the image of x when the triangle is reflected across this line yz. Which of the following is an expression for the perimeter in inches of quadrilateral x prime y xz? So if you take that triangle and reflect it over that line yz, you end up with this quadrilateral. Sides on this quadrilateral match up with the sides on this triangle. This side is y, that matches up with this. This side is z, that matches up with this. Question is, what's the perimeter? Well, to get the perimeter of that quadrilateral, just add up all the sides. You have y plus z plus z. Combine the like terms on that, it's 2y plus 2z. Remember, always keep an eye on your answer choices. We need to get this to look like one of these. So you're at 2y plus 2z right now. It's not showing up. But you could factor 2 out of that. If you factor 2 out of that, you're going to have 2 times the quantity y plus z, and that is letter K. The function f is an odd function if and only if f of negative x is equal to negative of f of x for every value of x in the domain of f. One of the functions graphed in the standard xy coordinate plane below is an odd function. Which one? One thing to know about odd functions is that they have 180 degrees symmetry about the origin. And the only one that fits that would be letter E. What is the real value of x in the equation log base 2 of 24 minus log base 2 of 3 equals log base 5 of x? Well, on the left side, you have log base 2 of 24 minus log base 2 of 3. Those two can be compressed with division. So you could write that as log base 2 of 24 over log base 2 of 3. Dividing those now, that's still equal to log base 5 of x. Log base 2 of 24 divided by log base 2 of 3, the bases are the same. You can divide the 24 by 3. It's going to be 8. So log base 2 of 8 is equal to log base 5 of x. Now on the left side, you can get the value of that. Log base 2 of 8, you're thinking 2 to what power is 8? That's the value of log base 2 of 8, and that is 3. So now you're looking at 3 equals log base 5 of x. Now to solve this for x, you're thinking 5 to the third power is the value of x. So x equals 5 to the third power, and that is going to be 125. So x equals 125, letter J.